Good afternoon. Today is Friday, October the 9th. Today in geometry, we looked at section 3.2. We talked about the angles that exist when you have parallel lines and a transversal cutting through them. So I will go to the share screen and show you some of the things we did today. So when you start with two parallel lines, so you have one line here, and you have a second line which is parallel to the first line. So we'll try to make this about as parallel as we can. And then you have a third line which is a transversal, which comes down at an angle. It could be perpendicular, but normally it's not. And then we label the angles so that you can see. So this would be angle 1, angle 2 here, angle 3 here, angle 4 here. And then you do the same thing down here with 5, 6, 7, and 8. Now, what we know about these angles, remember we have alternate interior. So if we look at the different types, we have alternate interior angles. And then we have an alternate interior angles here would be 4 and 6, and 3 and 5. And then we have consecutive interior angles. And consecutive interior angles would be 3 and 6, and 4 and 5. And then we have alternate exterior angles. And alternate exterior angles would be 1 and 7, and 2 and 6. And then we have the final type of angle we have is what is called corresponding angles. So the corresponding angles here are in the same position. If you look at each one of these intersections, the upper right angle 2 here and the upper right angle 6. So 2 and 6 are corresponding, 3 and 7 are corresponding, 1 and 5 are corresponding, and 4 and 8 are corresponding. So today what we did is we did some proofs. Now we are given in a postulate that the corresponding angles are congruent. So we know that 2 and 6 are congruent, 3 and 7 are congruent, 1 and 5 are congruent, and then 4 and 8 are congruent. And then we have the three theorems. Alternate interior angles here are congruent, consecutive interior angles are supplementary, and alternate exterior angles are congruent. Now, so if you look, if I'm trying to prove, for instance, that angle 4, so we'll come over here. Let's say we want to prove that angle 4 is congruent to angle 6. So we put our little congruent symbol on top of this equal sign here. Right? So now if you remember, see, so we know that 2 and 6 are congruent because of the, so we can say that angle 2 is congruent to angle 6 because that's the corresponding angle postulate. Remember, with postulates, we don't have to prove postulates. They are assumed to be true. So 2 and 6 are congruent because of the corresponding angle postulate. Now, we also know that angle 2 and 4 here are congruent. So we can say that angle 2 is congruent to angle 4. And remember, the reason there is because they are vertical angles. So if 2 and 4 are congruent and 2 and 6 are congruent, then I can come down here with my next statement and say that angle 4 is congruent to angle 6, and the reason there is because of substitution. I replace 2 here with what it's equal to, which is 4. So now I have proven that the alternate interior angles are congruent. So the same type of a procedure would be used to show that the consecutive interior angles are supplementary and that alternate interior angles are congruent. So I'm going to erase this and show you a type of problem now that we work on, and this is the type of problem that you will see with these types of theorems. So if we come back here and draw our picture again, so we have our 2 parallel lines. And they're cut by a transversal like this. So we have our angles, and we can number our angles once again. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, now I can have all different types of problems. The one thing I know here, for instance, if I come over here and say that angle 2 here is equal to 65 degrees, then I know that angle 4 is equal to 65 degrees because 2 and 4 are vertical. And then I know that angle 6 down here is 65 degrees because 4 and 6 are alternate interior angles, and we just proved that they are congruent. Then I can come over here to angle 8 and say that angle 8 is also 65 degrees because it's vertical with 6. Now, and then the other 4 angles, if you'll notice, angle 1 and angle 2 form a linear pair, which means they add to 180. So that means angle 1 over here, it's got to be 115 degrees because 115 plus 65 equals 180. Now, and you notice here, 1 and 4 are a linear pair, and 115 and 65 there also adds to 180. So the other angles, 3, 5, and 7 here are all equal to 115. So what you see here, when you have a pair of parallel lines cut by a transversal like this, 4 of the angles have one value and the other 4 have a second value, and the 2 values will always be supplementary because the 2 values will always add up to 180. Now, if you look at your homework problem, you got a setup similar to this, except the only addition to it is that you have a second line which comes right down through like this. So you get some more angles, but the same relationships hold. Like see here, you have this angle here and this angle here are corresponding. This angle here, 5 and 4 are corresponding. 5 and 2 are alternate exterior. And then this angle here and this angle up here are alternate exterior. So you can go through and determine the measures of those angles, and then you can put down the reasoning. So I'm going to stop sharing here. As always, if you have questions, send me an email and I will get back to you. And remember, we are not in school on Monday, so there will be no video for Monday. I will see you again on Tuesday.